Okay, steel plate strip of 150 mm width and 10 thickness is to be welded to another plate by a single transverse weld and double parallel weld. Okay, both type of weld are used, single transverse and double parallel weld. And there's an axial load is carried on this plate strip, and maximum tensile and shear stress is also given as 70 megapascal and 56 megapascal. You have to calculate the length of the fillet weld. Okay, here length of fillet weld means we have to find the length of the parallel fillet weld. This like 150 will be obviously the length of the transverse weld. That what they mean, find the length of fillet weld is to find the length of parallel fillet weld. Okay, when they have not mentioned, you have to know that the length of the fillet weld means we have to determine the parallel fillet weld. Okay, and what they're saying is the joint is subject to static loading condition. Okay, let's look at the solution. So okay, this is the figure according to your question. So this two plates are joined by one transverse weld. Okay, this weld. I mean this vertical weld is transverse, and these two are parallel weld. Okay, what they mentioned is two parallel weld and one single transverse weld means this is a figure. So these two plates are joined. The 150 is the width of the other plate, and this is subject to an axial load. Okay, first of all, write all the given condition. We have width of the plate 150 thickness, and the tensile stress and shear stress is also given as 70 megapascal and 56 megapascal. So the one thing we have to know before not to solve this problem is a combined loading. Okay. So what really happens is due to axial load, there will be a tensile effect and shear stress. Both stresses are developed. That's why we have given the both the value. In this question, both tensile stress and shear stress is given. So we'll be having both combined loading, shear loading and tensile loading due to this axial loading. Okay, both effect will be happen. So then I can write this equation. P is equal to PT plus P. P, P. So this P means the maximum load or strength of the plate, and PT is the load or strength due to tensile load, and P means due to shear stress or this parallel weld. Okay, this PT, this tensile will act along this transverse weld, and PP will be, I mean that shear load will be act along the parallel weld. Okay, that's what actually happens. This total load will be this as an axial load is exerted on both end P. As already mentioned the question, there will be an axial load, and that will be distributed among the transverse weld and parallel weld. And as this transverse weld is actually due to the tensile stress, and parallel will be having a shear stress. Okay, just keep that in mind. So first of all, you need to find the maximum load or total strength of the plate. Uh, can be found by sigma A. This W in dash means A. We know sigma is equal to the basic formula of stress is equal to sigma is equal to P by A. Right. So so the maximum load or strength of the plate can be found by using tensile stress. Okay, as the stress. Why using tensile stress? So we'll be able to get only the maximum load. The maximum load can be find only by using stress as tensile load, not shear stress. Okay. Or we can take the like the maximum stress is due to comparing the value of shear stress. The maximum will be maximum stress values for shear. I mean tensile stress. So you need to take that value in order to find the maximum load or strength of the plate. Into we have to find width of the, I mean plate is given, thickness of the plate is given, so that you can find the maximum load or strength that plate can occur. That will be around 105 into 10 raised to 3 Newton. Next, we know there is a single transverse weld and two parallel weld. For single transverse weld, this will be the formula. You can find it in the data book. So in this equation, you need to find PT. Okay, not to substitute in this equation, you need to find PT. So we know the value of sigma. Sigma due to tensile. I already mentioned this transverse fillet lab will be subject to tensile load. So obviously this stress value should be the tensile stress in the question. So 70. Remaining all the value we know. H is the I mean thickness of the plate. Okay, and LT is the, I mean length or width is also given 150 mm. So from that we get the value of tensile load as like 24,000 257.4 Newton. Similarly, we need to find the double parallel weld. Okay, I already told it's subject to shear stress. That transverse will be subject to tensile uh, stress, and parallel weld will be subject to shear stress. So this equation can also be find from the data book. So we know all the value. Here we don't have the value of LP. Okay, here LT means the length of the transverse weld means that actually it will be the width of the plate, right? So that's why you use the same value. But in the case of parallel weld, this horizontal distance we don't have that length of the parallel, and that is what they asked to find in the question. So from the second case, by double parallel weld, fillet weld, you will be only able to obtain a relation. Okay, in these relation can be put into this equation to find the value of LP. So our final step is substitute in this equation. P is equal to load due to tensile plus load to or load due to transverse weld and load in the parallel weld. So that equation you can use in final step to find the value of parallel weld. Okay, this is the way to solve this problem.